So, I see many of you remember, a few of you don't. Now notice I gave you a formula worksheet, so you could refer back to that. Arithmetic sequences and series. You won't be given this on the test, but this is a good thing to have in front of you today and then on your test review day and memorize. So a recursive definition, I'm just going to put R for recursive. That means writing it in terms of the previous term, a formula that will give you the next term given the previous term. So you'd say A sub n, that means any term will be the previous term. I saw many of you got it right. I saw Holly got it right. So she said A sub n minus 1, the previous term plus 2. Isn't that true? Everybody good. Many of you got that right. Then an explicit definition allows us to find any term in a sequence no matter what. You don't have to have the previous term. Now the formula for an arithmetic sequence, look at the top, is A sub n equals A sub 1 plus n minus 1 times the common difference. So our first term is 2, so A sub n equals 2 plus n minus 1. The common difference is 2, positive 2, so times 2. Then you would simplify. A sub n is equal to, that's 2n minus 2, correct? 2n minus 2, then you'll combine like terms. 2 minus 2 is 0, so we just have 2n. That would be our explicit definition. Questions on that? That should be pretty straightforward. Okay. Okay, so recall the difference between an arithmetic sequence and series. A sequence is just a sequence of numbers separated by commas. A series is addition, the sum of those things. So let's practice this so that we can remember how to do this, because we're going to be doing geometric today. So we're going to have to be looking at things the same. So if we have a finite arithmetic series, that means we know the start and end, we can sum them up. Correct, everybody? Start and end. All right, so this is A sub 1, and then this is A sub n. And we need to know, so here's the sum formula for a finite arithmetic series. We need to know n, which is the number of terms that we're summing up. So let's think about this. How much distance is between 2 and 22? 22 minus 2 is 20, right? Good. And then we're dividing it over intervals of 2, correct? So 10 would be, it took us adding 2 10 times. Now careful though, remember that didn't include the original 2, which we have got to add in. We're actually summing up 11 terms. Everybody good with that? So we would say S of 11 equals 11 over 2, and then times A sub 1, which is 2, plus A sub n, which is A sub 11, which is 22. So calculate that. Everybody go. Don't wait for me to do it. I already have done it. Calculate it. What do we get?
So you got 24.
132. Perfect. Now, one thing I have not said to this class, but I've said it to all my other classes, you can do this whole unit using a graphing calculator. I get that. I already know that. I will be taking away your I won't be allowing calculators on this test. Yeah, I'll give you a scientific calculator. So just so you know. All right, well, we haven't even needed a calculator for any of this stuff, have we? Besides summing up things. Okay, now let's rewrite this, because remember, this is the same thing as the sum sign. So let's rewrite this. Let's rewrite this in summation notation. We're going to have to be able to bounce back and forth. So we know that this sum sign just means those addition signs, so we're going to have a sum. Then remember, our lower limit is going to be 1, and then our upper limit will be how many terms we're summing up. So, yes. Oh, great question. Are we starting at the first term and summing up the first term? Great question. I'm glad you asked. I explained this way better B-Day because I just did. I was just assuming everybody could see it, which is my bad. You see how we're starting with the first term and summing up the first term on? That's why we're starting with 1. We're summing up the first term through the 11th term. Correct, everybody? Does that make sense a little bit better? And then our explicit formula was, what's the formula for arithmetic? It's
2n.
So it's going to be 2 and then plus n minus 1 times d, which we already did this one, right? 2, so it was just 2n. So our final answer will just be this 2n. Rewriting it in summation notation. This literally means the same thing as this. We can bounce back and forth. Any questions on that? Hopefully a good reminder. Okay, what I want you to do is find a sum. Ready, set, go. So first of all, you should be asking yourself, Is it arithmetic?
No.
Is it a line?
Wait.
So is the rate of change the same every time? Is the slope the same?
Yeah.
Okay, sweet. So now go ahead and use arithmetic, the sum formula for an arithmetic series, which is on your paper, and you should have it memorized. We just did this.
What paper? I don't. Oh, I did get that paper.
So how many terms are you summing up? Don't say 10. That'd be wrong. Then we're not understanding because this was really straightforward. Everybody listen, okay? Because this is like very, very easy, but I do understand that maybe I didn't explain this the best the first day to you guys, so I'm taking the blame. So everybody listen. We're summing up the 4th through 10th term. Does everybody understand that? So it's like skipping 1st, 2nd, and 3rd term. You're summing up only the 4th through 10th. So how many terms are we summing up? 4th, 5th, 6th, 7th, 8th, 9th, 10th. That's 7. 10 minus 4 is 6 plus 1 because we're also including the 4th term. That's 7 terms. So you'd say we're summing up 7 terms. 7 over 2. A sub 1 just means the first term you're summing up. So n equals 4. The 4th term is what our first thing that we're summing up. So plug in 4. So that would be, so we're actually doing a sub 4 technically. So 2 times 4 is 8. 8 plus 3. Does everybody understand? Everybody good with that? So we're going to be doing 11. The last term we're summing up is 10. So we're doing a sub, that would be a sub 7 technically. If we want to be technical. Well, that would still be 8, yeah. I mean, it just depends. Like the final term we're summing up. I should just say that. Do we all understand that though? So you plug in a 10. That'd be the last term we're summing up. So that would be a sub 10, I guess, if we're being technical still. Because I wrote this as a sub 4. So plug in 10. 2 times 10 is 20. 20 plus 3 is 23. So then your final term you're summing up is 23. Does that make sense? First term you're summing up to the ending term you're summing up. So then you calculate that and you should get 119. Questions on that? Okay. The geometric sequences and series. That was all arithmetic. It's the same idea with geometric. It's just now same idea with geometric as arithmetic. It's just now geometric. So you build a geometric sequence by multiplying each term by a constant. Just like with arithmetic, you add a constant. In a geometric sequence, the ratio of any term to its preceding term is a constant value. So we're going to be dealing with the ratio, which is division. So a geometric sequence will have a starting value A and a common ratio R. That's going to be a sequence of this form. Now let's think about why this makes sense. So if we have a starting value and we multiply by something, that'll give us the second term, correct? Now if we multiply by that same thing this again, that'll put us here. Now wouldn't that be multiplying by the common ratio twice? So that's why it's R squared. Does everybody make sense and see where this is coming from? Now if you get to the third thing, you've now multiplied, you started here, and you multiplied R 3 times, R cubed. Does everybody see why that makes sense? Okay, so everybody look at number 1 on your worksheet. Here we go. It's 3, 9, 27, 81. Is it arithmetic or geometric? Geometric, because we have a common ratio. 81 divided by 27 is 3. 27 divided by 9 is 3. 9 divided by 3 is 3. So our starting value is 3, and so A sub 1 is 3, and our common ratio is 3. Questions on that? So let's look at number 5. 1, comma 0.5, comma 0.25, comma 0.125. Is it arithmetic? No. And we could test that by taking our differences, and they're not the same. Now let's test if it's geometric. Do 0.125 divided by 0.25. You get 0.5. Take 0.25 divided by 0.5. You get 0.5. Take 0.5 divided by 1. We get 0.5. Does everybody see how the common ratio is the same? So our A sub 1 was 1, and our common ratio was 1/2. Everybody good with that? We're multiplying by 1/2 each time. It's getting smaller and smaller. Do you have a question over here? Okay, sweet. Then do 1 through 9 really quickly. Practice getting the common ratio. All right, I think you guys get how to determine if it's geometric or not. So now we're going to do just like with an arithmetic an arithmetic sequence, there's an explicit formula and a recursive formula to generate any term in the sequence. So writing a formula to find any term in a geometric sequence, there's a recursive definition and an explicit definition, just like in arithmetic. So recursive definition, once again, is a formula written in terms of the previous term. So it would be a sub n is equal to the previous term times by the common ratio. You just take the previous term and multiply it by 2. Does that make sense? That would be an example. So look at number 10. Let's write a recursive definition. 2, 4, 8. Aren't we multiplying by 2 every time? So our recursive definition would be a sub n equals the previous term, which is a sub n minus 1 times 2. That would be a recursive definition. However, once again, that's not super helpful because you would need the previous term to find the next term. So we really like an explicit definition better because you don't need the previous term. So this is, you'll want this. It's on your worksheet. I've already written it for you. Yes? Basically, we have to have a starting point. So, like, if you're looking at, so for n greater than 1, so 2 would be if we plug in a 2 here, a sub 2, that would be we'd have the first term. If we plug in something before 1, like let's say we plug in 0, that would be the negative 1th term, which is the term before a sub 0. So that's just what it's saying. You have to have a first term to be able to go. Does that make sense? We have to have a starting point, a sub 1. Good question. Okay, an explicit definition is this. You're gonna need that memorized. So to find any term in a geometric sequence, you'll take a sub 1, the first term, multiplied by the ratio raised to the n minus 1. So basically, this is the number of times you're going to be multiplying by the ratio to get to that term. So if we're wanting the 4th term, are we going to be multiplying the ratio 3 times, everybody? So the formula makes sense, so it shouldn't be hard to memorize. Congrats, that's exciting. Okay, here we go. Let's apply the formula. Number 11, it says find the 10th term. So find the 10th term. So first of all, we would check, because on the test, I'm not going to say this is geometric or arithmetic. You have to determine so that you know the correct formula. So 9 divided by 3 is 3. 3 divided by 1 is 3. Oh, this is geometric. So then you'd say, what's the explicit formula for geometric? It's a sub n is equal to a sub 1 times by the ratio raised to the n minus 1. So a sub 10 is equal to, a sub 1 is the initial term, which is 1, times by the common ratio of 3. So we're multiplying 3 how many times to get to the 10th term? We have 10 minus 1, which is 9. So make sense of the formula. Does everybody see how if we started with 1, we would have to multiply 3 9 more times to get to that 10th term? Okay, so we will have number 11 will be 19,683. Okay, number 12. Once again, be very careful to check if it's geometric, which we know it is because it's the worksheet, so let's practice though. Negative 18 divided by 6 is negative 3. 6 divided by negative 2 is negative 3. So it is geometric. We are multiplying by negative 3 each time. So we're doing a sub 10 is equal to the starting value. Negative 2 is where we started. Now we're multiplying negative 3 9 times. 10 minus 1 is 9. Now if you do that, you're going to get 39,366. And once again, I just can't stress it enough. Notice how it's bouncing from a negative to a positive, negative to a positive. It makes sense if you think about multiplying negative numbers to negative numbers and negative numbers to positive numbers. Everybody feeling comfortable with something like this? Okay, sweet. So let's do some more advanced ones now. If you get that, then everybody, let's look up here and do some more advanced ones where it will take a little bit more thinking. So it says, given that the second term in a sequence is 6 and the 5th term in a sequence is 48, what's the common ratio and what would be the 8th term? This one's going to take a little bit more thought. Anytime you have no idea what you're doing, try to figure out, plug in something what you know. First of all, if we're dealing with sequences, we definitely know this formula, right? This allows us to find any term in a sequence. So that'd be the first thing I write down. I'm probably going to be using that. So it says the second term in a sequence is 6. So wouldn't that be a sub 2 equals 6, everybody? Okay, and then the fifth term in the sequence is 48. So a sub 5 equals 48. Okay, let's think about this. We have no idea what a sub 1 is, because we don't even know what the r is either. So r, we don't know. All right, so let's plug in what we know here. So we know that a sub 2 is 6. So let's go ahead and make a formula here. So let's do 6, because that's a sub 2 is equal to a sub 1. We don't know that. We don't know r. But we do know n. If a sub 2, then won't it be 2 minus 1, everybody? So then 2 minus 1. So we know that that is a true statement. Let's come up with another true statement. So I'm going to actually rewrite that simplified. We have 6 is equal to a sub 1 times r to the first power, right? Okay, let's keep going. Now that's not enough to solve because we have 2 unknowns. Everybody good with that? So let's set up another true statement. So another true statement would be, we know a sub 5 is 48, so we know that 48 will be equal to the first term times by the common ratio raised to the 5 minus 1. So we know that this is 48 will be equal to a sub 1 times r to the fourth. Okay, we know this. We know these two things. So now we have a system of equations. These are both true at the same time. So let's solve by, let's divide this straight down. In fact, I don't want to have to deal with fractions, so I'm going to put this one on top. We're going to combine these now. We're going to divide straight down, because then won't that get rid of a sub 1? If I divide straight down. Okay, so I'm going to put 48 on top just because it's larger. We'll still be okay if we don't. We'll just be dealing with negative exponents and fractions and stuff, so we'll have to flip things, which we could do. But I'm going to just say, I'm going to put 48 equals a sub 1 times r to the fourth on top, and on bottom I'm putting 6 equals a sub 1 and then r to the first. Let's divide straight down. What's 48 divided by 6? 8, and then a sub 1 divided by a sub 1 is nothing. When you divide the same base, what do we do with our exponents? Subtract. 4 minus 1 is, so we have r cubed is going to be equal to 3. So now let's solve for r. Cube root it, right? Yep, so we cube root both sides of the equation, and we get r is equal to 2. Now we have a lot more information here. So our common ratio is 2. Does everybody understand? Okay? So we found the common ratio, it's r equals 2. So now think about it. What would be the 8th term? So we could just use the formula now, right? A sub 8. Well, we need the first, like, you get what I'm saying? The explicit formula allows us to find any term in a sequence, correct? So let's use that now. Let's answer the second question. So we want a sub 8, which will be equal to a sub 1. We need the first term. If a sub 2 was 6, what would have been the first term that came right before that? 3, right? Isn't it what multiplies to be, so divide it by 2, correct? Everybody? 3 would have been our first one. So a sub 1 was 3, and then we have our n minus 1, no, sorry, I'm doing arithmetic in my head, times by r, which is 2 raised to the n minus 1, 8 minus 1, which is 7. So a sub 8 will be equal to 3 times 2 raised to the 7. So go, calculate that. 384. Sweet. Any questions on that? And if we were desperate, couldn't we have started at the 5th and multiplied 2 a couple more times and been there? Does that make sense, everybody? We could check it. Okay, awesome. Okay, so do 10 through 19. Practice some of those, and then we'll see where we're at. Okay, the next thing, it says find the missing term of each geometric sequence. I'm going to show you algebraically what you're doing. So you're actually finding what's called a geometric mean, which means a geometric average. So if I put an x here, because I don't know what it is, then a true statement would be 16 over x equals x over 4, correct? Isn't that true? This divided by this better be equal to this over divided by this, correct? The common ratio should be the same. Do you see how my true statement makes sense? Won't this divided by this be the same as this divided by this? This divided by the next. Do you get what I'm saying? So now let's solve for x. So we'll multiply up. 16 times 4,
54.
right? 64 is correct, and then x times x is x squared. So we have 64 is equal to x squared. Solve for x, what would we do?
Plus or minus 8.
Good, square root both sides, and I like that you remembered that root cancel out power. X could really equal plus or minus 8, correct? Isn't that true? Because think about it. 4 times, so x is equal to plus or minus 8. So if we put an 8 here, then what would we be multiplying by? 2. If we put a negative 8 there, we would be multiplying by negative 2, and that would still work, correct? Okay. Sweet. So plus or minus 8, it's one of those two answers. Does that make sense, everyone?
Yeah.
Okay. If you see on the online homework, it says, what's the geometric mean? That is literally what we did. We found the geometric average. We just found the average here. Okay, now let's do one that's a little bit more thinking involved. So it says, find the missing terms. I'm sure there's a couple different ways you could do this.
Find the middle one first.
This is, okay, you could find the middle one first. That is one way of doing it. Absolutely. Is that how you want to do it? So, and I thought through this one like this, and that's correct. You could do that. Go ahead and do that. This is how I thought through this one. A sub 1 is 4. A sub 1, 2, 3, 4, 5. This is A sub 5, correct? Everybody good with that? So let's set ourselves up a true statement. We know to find any term in a sequence, we use the formula A sub n is equal to A sub 1 times by r raised to the n minus 1. Is everybody following me? Let's plug in what we know. We know that the fifth term is 324. So let's do 324 is equal to our A sub 1 is 4. We don't know r. And then we did A sub 5. So we'll be doing 5 minus 1, which is 4. So I'm just using algebra to find it. Does that make sense?
Yeah. Wait.
We know A sub n. So we know A sub 5, correct? Does that make sense? So I plugged in a 5 here, and I plugged in A sub 5. And then we know A sub 1 is 4. Now we'll solve for r, but other people don't, because I can tell by their faces. So that's why I'm continuing. No, there's other people. Is anybody confused, or does anyone have a question where I can go into better detail? You sure? Okay, so let's solve for r. What would be my first step? Okay, what is that? Divide by 4. 81 is equal to r to the 4th, so then we'll fourth root it, correct? So fourth root it.
3.
Plus or minus
3.
3 equals r. So our common ratio is plus or minus 3. So and on the online homework, if that ever happens, it'll give you two options. It could be these three things or these three things. Does that make sense? So our ratio, let's go with positive 3. So if r equals 3, we'll multiply by 3. So 4 times 3 is 12. Times 3 is 108. Perfect. And then if for r equals negative 3, we would have put in, there'll be another box for those. 4 times negative 3 is negative 12. And
36.
Positive 36, and then times by negative 3 is negative 108. Does everybody see how to do that? Okay. Now in this one we didn't find r. We could have actually solved this one very similar to the one we just did. Does that make sense? So there's just many different ways to do these. That's what makes them hard. Okay, so do 20 through 31. Ready, set, go. Everybody, now we're going to go flip to the next page. We're going to be talking about series now, geometric series. So the first thing we're going to do is find the sum of a finite geometric series. Remember that finite means you know the start and end. So here's the formula. It's on your work. I gave you a paper with the formula for a finite geometric series. So the sum, you need to know the number of terms of a sub 1 times by 1 minus r raised to the n divided by 1 minus r. So this is the formula. You need to know the number of terms we're summing up. A sub 1 is the first term and r is the common ratio. So let's go to our first example. So it says, evaluate each finite series for the specific number of terms. So we're summing up, it tells us 10 terms. That makes it really easy on us. So we're summing up 10 terms, so we'll do S of 10, summing up 10 terms. A sub 1 is 40 times 1 minus the common ratio, which is, are we multiplying by 1/2, everybody? 10 divided by 20 is a half. 20 divided by 40 is a half. So our r is a half. So we'll be doing 1 minus a half raised to the n, so raised to the 10th. and then divided by 1 minus a half. 1 minus r is a half. Make sure that only a half is raised to the 10th, so you've got to type this into your calculator correctly. How about you all practice? Use your graphing calculator and practice typing it in. Let's see if you get it right. So you should get this. 79.9. So the sum of those 10 terms is 79.9. So that tends to be the hardest part for people to type it in correctly. Now, one thing that people do to type in wrong is they'll divide and they'll just type in 1 minus a half. You need to actually calculate that and just divide by a half. Does that make sense, everybody? If your calculator is pretty picky on how you type it in. Did you all get 79.9? If so, I don't need to spend time on it. So, if you do, nod your head. You all got it.
19. Oh,
Then you're typing it in wrong, so let's go through it.
No.
Do you need me to type it in?
I got 19.9.
So you're typing it in wrong.
Oh,
What the heck? So you'll be typing it in like this. So we have on top, we have our 40. So 40 times 1 minus, I'm going to just type in, well, you could type it in like this, minus parentheses 1 half, for close your parentheses, raised to the 10th. Now I'm closing my parentheses around that part. Then I'm going to hit divided by, and then this part I am going to actually calculate. 1 minus a half is 1 half, correct? So divided by parentheses, 1 divided by 2. 79.9. You've got to be really careful. Does everybody see how you've just got to be so careful? Okay. Sweet. Okay. Do 1 through 6. That's what we'll practice before lunch. We have a couple minutes. Do a couple of 1 through 6. So with this one, if I said to you find the sum, to be able to find the sum, we need to know the number of terms, correct? So we have our first term, a sub 1. We don't know what this is, a sub n. So everybody, let's think through how we can think through this. Okay, so we will use our explicit formula and plug in what we know. So we know a sub n is 3,072. So that's equal to a sub 1 is 3. And then we have times r. What's our common ratio here? Are we multiplying by 2? 2 raised to the, now we don't know what n is, so we'll say n minus 1. Okay, solve for n. Divide by 3, what is that? 1024 is equal to 2 to the n minus 1. Now here's the thing. I can teach you this a couple different ways. So first of all, we're trying to solve for n. But the only way so far that we've learned how to do this is this way. So we could get this 1024 into base 2 because this is up in the exponent. You guys understand you can't divide by 2, correct? Because it's 2 raised to the n minus 1. So 2 to the what power equals 1024. Start testing. 2 to the 5th, 6th, 7th, 8th, 9th, 10th. 2 to the 10th. So we have 2 to the 10th is equal to 2 to the n minus 1. Now, since they're both base 2, now we can just say, when does 10 equal n minus 1? Solve for n. So add 1, 11 equals n. So now we know we're summing up 11 terms. Does that make sense, everybody? Okay, so the sum of 11 terms is equal to a sub 1, which is 3, times 1 minus r, which was 2, raised to the 11th, and then all over 1 minus 2. So if you type that into your calculator, the sum of those 11 terms will be, I'm just going to tell you, it's going to be 6,141. So did everyone see how I had to first go through and use algebra to find the number of terms we're summing up? When we do that on the homework. Okay. All right. Find the sum of this finite geometric series. Go on your whiteboards or on your paper. Find the sum of this for me. Show me you can do this.
Okay.
So you did this in the formula and you got 315. That would be correct. Okay. All right. So with this one, everybody, looking at it, if I said to you, if I gave you this, doesn't it go without being said that this means find the sum? right? So find the sum. Let's use the formula. 0 to 20. Careful, that's how many terms? 21 terms. So we're summing up 21 terms is equal to a sub 1. That'd be plugging in 0. Any base to the 0 power is 1. So our first term would be 4. And we have 1 minus r. Our r is what we're multiplying by, so isn't it a half? So from our formula, we know it's a half. And then we have raised to the 21, and then divided by 1 minus a half on bottom, which is just a half. So we could calculate that. I'll just give you the answer. I just wanted you to see something in the different form. And you will get, I thought I did it. I must have added this one on there. Oh, no, I did. So we get 7.99. Everybody good with that? Okay, so that was fine. That's the formula to find the sum of a finite geometric series. Now we're going to talk about finding the sum of an infinite geometric series. So, the terms of a geometric series grow rapidly when a common ratio is greater than 1. That makes sense. If I keep multiplying by 2, isn't it just getting rapidly larger? If I multiply by negative 2, won't it just be getting rapidly smaller, but at a large rate, correct, everybody? Okay, it says likewise, they diminish rapidly when the common ratio is between 0 and 1. Or in other words, if your common ratio is a fraction that is between 0 and 1, then it's diminishing rapidly. In fact, they diminish so rapidly that an infinite geometric series will have a finite sum. Meaning, if we have, and I'll get to the meaning in just a second. So an infinite geometric series can have a sum if your R value is less than, and we always look at the absolute value of R. So if our ratio is less than 1, then we will have a sum. And I'll explain why in a second. And then you'll say, oh, that does make sense. And then if our R value is greater, if our ratio is getting larger and larger, if it's greater than or equal to 1, it won't have a finite sum. Because if something's just getting larger and larger, so anyways, let me show you before I explain. All right. So everybody look up here at this example so that it will make sense of why this is. So let's look at this series, for example. Do you see how we're multiplying by 2? Our common ratio is 2. Isn't 2 greater than 1? Isn't this just getting larger and larger? And we would never know when to stop adding, correct? We'd just be, like, we can't find a sum on this. Does everybody see? We would never know when to stop adding. It's infinite. So that would be having no sum, and that's called, it diverges. So if it has no sum, it diverges. You might want to write that down because you're going to need that word. So once again, if a geometric series has no sum because the R value is greater than 1, then it will have no sum, so it diverges. Now think about something like this. 2 plus 1/3 plus 1/18 plus 1/08 plus 1 over 6/48. Our common ratio is 1 over 6. Isn't this just getting smaller and smaller and smaller and smaller and teenier and smaller? Now think about it. Isn't this eventually going to get so small that we're basically adding 0? Does that make sense? So then that would have a sum. So that converges, it converges to a sum. So this is an infinite series. So the reason I did this plus 0 is because I'm saying it's going to keep getting smaller and smaller. It's never going to actually be 0, but it's going to approach 0. So pretty soon we're going to be basically adding nothing more to it. No, it's getting smaller and smaller. It's going close. Aren't these fractions getting closer to 0? Right, so it is going to get larger, but eventually, do you get what I'm saying? Eventually we're going to be adding a 0, because the fraction will be so teeny. Yes. Yep, it is. It's exactly like it is. It's exactly what it is. It's an asymptote, exactly. Yep, so these are they're approaching 0, so we'll be adding 0 eventually. So that's considered convergence. And this is the formula for an infinite. You've got that formula on your paper. This is the formula to find the sum of an infinite geometric series, when you can find the sum. So we can only find the sum if it's getting smaller and smaller. Does that make sense? Because then if it's getting smaller and smaller, then it's eventually going to be 0 that we're adding. So we all get when we can and cannot find a sum. Okay. Okay, so some of you might care, some of you might not. But for those of you that are interested, these formulas are actually the exact same thing. Just one thing to think about. So those of you that care, we know that this is the sum of a finite series. A sub 1 times 1 minus r raised to the n divided by 1 minus r. Now I just told you the formula. If we can find the sum, it'll be this formula. Now here's why they are the same thing. Here's why. Let's say we can only use this if our ratio is less than 1, if it's getting smaller and smaller. Because then it's going to get so small that we're basically adding 0. So let's take a half, for example. Let's plug a half in as our ratio. Let's focus on this piece and think what's happening here. If we have a half raised to the n power, let's do the sum of something really, really large. So I'm just doing like infinity, like really, really large. Won't any fraction raised to something huge be basically 0? Like, for example, type into your calculator, a parenthesis, 1 divided by 2, raised to the 300 power. There's not. Because infinity is just a place, not a number. I'm just saying an infinitely large number. Plug in 300. You get basically 0. You get what I'm saying? So as this gets really large, this piece basically becomes 0. Because any fraction that's less than 1 raised to a really large power is going to get teenier and teenier until it's basically 0. So now if we have 1 minus 0, then that's just 1. That leaves me with a sub 1 over 1 minus r, which is our formula. Does everybody see that? Now that's happening because, once again, this piece of the formula is becoming 0 as we get larger and larger. Yeah, so it's literally the exact same formula, notice? Cross that out, we have the same formula. Okay? Okay, so let's determine whether each is infinite or finite, determine whether each infinite series diverges or converges. State whether each series has a sum. If it does, find it. Look at number 8. Can we find the sum of this? Is our ratio getting smaller and smaller? I mean, is this getting smaller and smaller? Yes. What's our r value? Good. Yep. We're timesing by a half each time, aren't we? So r is 1/2. So everybody, we can find the sum, so that we would say it converges. It converges to a sum. So let's use the formula. It's an easy formula. S is equal to a sub 1, which is 3 over 1 minus r, 1 minus a half. So that is 3 divided by a half, which is 6. So it converged to 6. It summed up to be 6. We got to a point basically where we were adding 0. So it went to 6. So it approached 6. Yes. The sum of this, it converges to 6. If we started adding these and kept adding until we're basically adding 0, the sum will add up to be 6.
Oh,
does that make sense? The sum of those numbers. Good question. Okay, number 9. Can we find the sum?
Yeah.
Yeah, it's getting smaller and smaller, right? So our r value is 1/2. So now we'd say, yeah, we can find the sum, even though we don't know the end. We're basically going to be adding 0 clear down there. So s is equal to a sub 1, which is 4 over 1 minus a half. So what's our sum going to be? 4 divided by a half? 8. So the sum of all those things will converge to 8. So we'd say, yes, it converges to 8.
Oh, yeah. Wait, converges is going.
It's just our sum is going towards 8. Like we're getting closer and closer to 8. You know what I mean? Like, yeah. If it diverges, then if it has no sum, then that's considered diverging. Okay, so practice 8 through 21 for a second, and then we'll keep. That's all we have to learn, but we'll just look at a few a little differently. Okay, ready, set, go. I'll give you a little bit of time to do some. 28 and 29, same idea, just different format. Because we know that this format just means the sum. That summation sign, that sigma, is just the sum. So it says, evaluate each infinite series that has a sum. So on the test and on the homework, the first thing you would say is, can I actually find the sum of this? So first of all, it's geometric, correct?
Yeah.
Look at the formula. If it was arithmetic, it would be linear. Does everybody understand? So it's geometric. And you'd say, I can find the sum of an infinite geometric, but my r, my ratio, has to be less than 1. The absolute value has to be less than 1. So what's 2/3? That's like 0.6, correct? So that is less than 1. So these are getting smaller and smaller. So this one does have a sum. So we would say, yes, it converges. Now let's actually find it. So the sum of an infinite geometric series is a sub 1 over 1 minus r. So what is a sub 1? Well, let's plug in 1. 1 minus 1 is 0. 2/3 to the 0 power is 1. So 5 will be our first thing, our initial value. Does everybody understand? So we have 5 over 1 minus 2/3. Our r is 2/3. So that's going to be equal to 15. So the sum will go converge towards 15. Everybody good with that? Do I need to actually let you type that in? You are good? Okay. What about number 29? Is there a sum on this infinite geometric series?
No.
No, right? Isn't negative 2.1 our r?
Yeah.
Isn't that it's getting smaller and smaller, but it's at a very large rate, right? Everybody, do you get what I'm saying? It's not approaching 0. Does everybody get what I'm saying? So each time you're multiplying by negative 2.1. So we will never know when to stop summing. So this one has no sum, so it diverges. We can't find a sum. We would not know when to stop adding. Okay, do 22 through 31. That is the last of the lesson. Yeah. So you're doing 22 through 31. That's the last of the lesson. You should be good to be able to do the online homework and to be successful in test. You've learned the entire unit, and today we really reviewed all of it except for Pascal's triangle. So.